Hello guys. So let's talking about this problem. So this is famous problem. Basically, somebody give you an array and you need to find a majority element. Yeah, so majority element divided appear as more than n over 2 times. Okay, and you can just go to solution. And the famous theorem that algorithm you can use is this Boyle-Moore voting algorithm. So basically, initialize the counts and for nums, if you see the count equals 0, then you just change your candidate. And if the same as candidate, add 1, -1, and final return candidate. Oh, so this is a very powerful algorithm, right? So for example, let's see, 3 to 3. Then you see 3, you count 1. You see 2, you count -1. And then that disappears, so you will set can to 2. But then you see 3, so then you will set answer 3. Okay, so the problem is that the algorithm is very simple, right? But the problem is that why this is true. Why this is true. Okay, so in this quick video, I will give the proof. Okay, why this is true. Okay, so I think everybody understands the algorithm. So let's see the proof. Okay, so there are two cases, right? So the first case is that the counter, let's say counter C, never goes to 0. Never goes to 0. The second case is that the counter C goes to 0 at some point. Okay, so let's see the first case. So if the counter C never goes to 0, then definitely this counter will be majority, right? Because C is the same as the candy, the candy. In A case, if the C never goes to 0, then the C will be the number of candy minus the number of non-candy, right? But this array has n, and there are at least n over 2 greater than half, greater than there at least n over 2 plus 1 of that guy, which is a majority element. So if A counter never goes to 0, then you can definitely claim that the A will be majority, right? Because that means the counter minus non-counter at least greater than 0, right? But you go through it, that at most n of them divided by, there is only one majority element, right? So in the A case, that everything looks trivial. So how about the B case? What is the case if the B goes to 0? Okay, so let's consider this. Suppose this counter become 0 at the first list. Okay, let's say this is array 1 and this is array 2. So in array 1, that if the counter after this part goes to 0, then there are actually two cases. The first case is that the majority M not happen. So majority M do not happen in array 1. Right, then you just redo the array 2, then they become a reduction, right? So this is a reduction step. So everything will still trivial. But there is a problem that maybe M happen in array 1. Okay, but my claim is that M at most has shown what? Let's see that this is X, right? M at most shown X or divided by 2 times. Okay, so notice that C is 0, right? So X must be even, right? Because S at most and plus or minus 1. So this is okay. Right, so M at most has shown X divided by 2. Why? Otherwise the counter will not be 0, right? Otherwise the counter will not be 0. Otherwise the counter will not be 0, right? But this tell you that the rest, the M must in the rest must shown at least n minus X divided by 2 has. So this guy still be the majority. Okay, so this is a reduction step. Okay, so this is a proof that why this strange algorithm actually works. Okay, so see you guys next videos. That's it.